And T-minus 60, just so that I can time myself appropriately. Well, you guys seem pretty much here. Do you want to wait for anyone else, or do you care about them? All right. All right. Well, welcome. My name is Jarrod Overson. I'm a consultant under Gossamer. I'm currently on contract with Riot Games, which is an awesome company if anyone's interested in working in Santa Monica. And I'm here to talk about continuous delivery for the web platform. Going to do this in almost 3 phases. 3 phases. What is continuous delivery? Why continuously deliver? I'm not going to be able to walk here. Yeah. All right. And how do you deliver JavaScript? Continuous delivery is the automated path from development to production. Continuous delivery is not continuous integration. Continuous integration is a part of continuous delivery, but continuous delivery extends that path to get your code all the way from dev complete to production. The main goal of continuous delivery is to deliver working software as early and quickly as possible. This does not mean rushing to get features done and delivering full features as quickly as possible. It's just code, just little bits of code. Doesn't need to be full features at all. It could be features, but they could be released dark. They're under a feature flag. They might not be seen by any normal user. 5 keys of continuous delivery are automation, 1. Tests, and this could be unit tests, system tests, regression tests, integration tests, anything that verifies that something is working without you looking at it. Automated tests, of course. 3rd is automation. 4th is monitoring, so that you don't actually have to be on a system in order to determine its health. This could be health checks, could be statistics, could be how many people have logged in a day, how many people have downloaded something, anything that allows you to look at a trend and get a pretty good understanding of whether or not things are going okay or not okay. And of course, alerts based off of those stats are supposed to be automated. And in case you're new here, the 5th is automation. And these are all important, but I consider continuous delivery so important that if you had to delay continuous delivery in order to get more tests or more monitoring, I would recommend not. Automation is really the key here. If you don't have tests and you don't have monitoring, you're already deploying. It's already okay. You're not doing much differently. You're still doing it kind of poorly, but you can still do it quicker and you can still get things out more sooner. If somebody dropped into your project right now, how long would it take them to get up and running? Are they going to go through a document? Are you going to tell them a bunch of shell commands to get something running? How long is it going to take them to deploy that project? Is it going to be quick? Do you kind of balk at either of those questions? Be like, oh Christ, I need to figure out what the hell I'm going to tell this new guy? You got an automation problem. You need to get things down so that somebody comes in, it's one command up and running. Install dependencies, get your application environment bootstrapped, make sure that you have everything going. You need to get this done because if you're the person who holds that, you just don't want to be. It's stressful, it sucks. It sucks for the company, it sucks for you. It's not a good place to be. So traditional delivery, you develop a feature, you pass it on to QA, you deploy it. As QA takes a while because you didn't get that feature to them until it was pretty much done, features start backing up because you're not going to sit there and wait for everything to get done. You're going to move on to the next thing. And features keep on backing up. And inevitably, QA tosses that feature back to you because there was some issue. And that's all right. That's normal. It's supposed to happen. The problem is that you're already 2 features behind. That code that QA was working on was maybe 2 days out or maybe 6 weeks out. Who knows? You don't want to be context switching back and forth. And now that that's gone back, you've got a free queue to deploy, so somebody inevitably is going to be like, hey, why don't we just release this? Maybe it's another engineer, maybe it's a manager, maybe it's somebody from product. It makes sense. And of course, your first instinct there is, what the hell are you talking about? We can't just jump back and forth doing that. You can't just touch code that's been out, or that's been sitting there for 6 weeks and expect it to go ahead of something that you were already expecting to be in production. I mean, you don't know whether or not there's going to be regression issues by reverting one and merging one back in, and then what if that one comes back from QA and the other one gets promoted again, then you have to go through that same cycle again. It just doesn't work. And I'm sure, I mean, there was a laughter here. We've all done this. It's a pain in the ass. It's not comfortable. It adds stress. It adds complexity. It adds frustration. The delivery process ends up looking like this. You've got peaks of code where a lot gets delivered. It might be one massive feature, it might be a bunch of small features. And then you have valleys where on the outside it looks like nothing's getting done. And each peak represents stress, anxiety. If you haven't delivered anything about 4 or 5 weeks, you've got a bunch of features, you're not looking forward to that next deployment. A lot of eyes are on you. A lot of the companies waiting for some massive change in the product, and it's uncomfortable. And when you start looking at code as risk and time as cost, then it becomes more apparent how flawed that structure actually is. And it starts getting scarier. There's cost as time progresses no matter what. Continuous delivery, sporadic delivery, whatever you want to call it. As time progresses, the company is paying money somewhere. And at every valley there, you're not presenting any value. So you might be doing something, you might feel like you're being very, very productive, you might be getting a lot done, but if the user never sees it, then it's not really worth much. Continuous delivery, on the other hand, is small bits of code released over and over and over again. It could be daily. I mean, you hear numbers, I'm sure, from the Amazons, the Googles of the world. We deliver 5,000 times a day, but that means like once every 2 seconds. But it doesn't necessarily mean to be the same product being released. You can have continuous delivery among many different products, and as long as those keep on going out, then it's still okay. You could release one product once every 2 days if that's all you're really working on. It's not that big of a deal. You don't need to think like, oh wow, it just needs to keep on pushing stuff out. The problem also with sporadic delivery is that if you release something, let's say on that first peak there, and it ends up not being the right choice. Maybe there wasn't enough user testing, maybe it just didn't end up doing what you thought would happen. You probably can't address it at the second peak because those features are already in the pipeline. Those features were already being worked on, already being developed, and the best you really have to address that is the third peak, but you're not even going to do that. There was so much risk, stress, development in that feature getting out that you're probably just going to keep that crappy feature in. Does that sound familiar? I've dealt with that plenty of times, and it might just be my perspective on product, but that's different. So the gist here really is to just get as much value to the user quickly and with little risk. And this, again, does not necessarily mean releasing features to a user. This could just be releasing small bits of code so that the risk to the user is significantly lessened. But I'd be somewhat dishonest if I told you I was coming here from the product perspective, because really, at the end of the day, this is about you. What are you doing? What are you doing in your life that makes you happy? What makes you stressed? You're only here for a limited period of time. You don't want to go to work and be stressed out all day. That sucks. You don't have to listen for a product's desire for a deployment down the line. You don't have to be stressed out about next thing that's coming down the line. Continuous delivery makes your life better. It reduces your stress, reduces anxiety. It reduces process. No one wants to be in deployment meetings. No one wants to deal with massively spec'd out features that don't go anywhere. It increases accountability. If your code is constantly lumped in with a lot of other developers' code, then if there's something that goes wrong, everybody on that development team looks like they're at fault. In continuous delivery, if you're constantly pushing out small bits of code that you individually worked on, it's much more easy to get visibility into the code and quality of the development practices. It exposes plenty of waste because, I mean, if deployments we're waiting on button pushers or email senders, email repliers, and you start automating all that process, it leaves a lot of people able to do a lot better things. And I put the last two as kind of jokes, but if you are less stressed and less anxious, then we're not too far away from the truth. So how many people work in Agile shops right now? It's a pretty common buzzword, lean, Kanban, Scrum, whatever. So you have retrospectives probably, plannings, backlog reviews, stuff like that. How many times have you come across the question, when can we mark this done? When can we move this to the finished column? When can we check this off? And you as engineers, you think, well, hey, when do we check this off? When is it done? That's a perfectly legitimate question. You start talking about QA, you start talking about deployments teams if you have them, systems, maybe product, like when does it look done enough to be considered done? And after 15, 20 minutes, you start getting really annoyed and you're like, all right, just whatever, we'll mark it done when we do this. And it's a sucky solution because it's a bad question for a bad problem. And no matter what, you're going to come back to that question in 6 weeks because someone somewhere in the company doesn't feel like it's done when it's marked done. So that question is going to come up and it's going to be annoying. It's going to suck the soul out of you. So if you're not this guy, now's a good time for questions. Or you can bolt. That's cool. It's not a big deal for me. That's fine. There's a lot of people here. People probably like chairs. Does anyone have questions about continuous delivery or why you might want to do it? You can talk. Oh, come on, guys. We're ahead of time. All right. So, to get started, and now you are all 100% in on this, right? Yeah. Woo. All right, so you add process. You schedule a meeting. You go over continuous delivery in a perfect world scenario. You start talking about if you had all the time in the world and all the money in the world, what cool things could you do for continuous delivery? Maybe you've been talking about using Chef or Puppet or something along those lines to automate the spin up of servers, to automate configuration, to do deployments. Maybe you're thinking about moving to Amazon. You want to automate that process, look at the build tools, maybe maybe playing with Node if you haven't before in order to start automating some of those things. And maybe you're already on Amazon and you want to start deploying baked images internationally, which is so cool. And then you come back to reality and you're like, holy crap, that's way too much work and it's going to be way too expensive for us to actually get there. And that's the last thing you want to do when you're trying to make your life better is to add all this complexity. And besides, you don't have unit tests. Come on, be honest with yourself. Come on. And even if you do, they take 45 minutes because they're crappy unit tests? You don't have monitoring, and you really can't do continuous delivery without monitoring. And you're not Etsy, you're not Netflix. Continuous delivery is for somebody else. It's for a company that's bigger than yours, or a company that's smaller than yours, or a company that has a deployment team, or doesn't have a deployment team, or whatever. It's just not for you. And that's not a very appropriate way to think, but you're going to have those thoughts, and you're going to have people who think that way and are going to bring that up to you, and you're going to have to resist them. It's going to be frustrating, it's going to be a pain in the ass, but this is a massive change. Traditional delivery exists because it's optimized for lack of decision. So when you start moving that boulder, it's going to be a pain in the ass, and you're going to have a bit of work, and the best way to start doing that is to remove as many hurdles as possible. So start deploying every day, today. Well, no, not on this Wi-Fi. Tomorrow, when you get home. Even if there are no changes, especially if there are no changes. Because what you're trying to do is avoid the fear and risk of deploying new code. So if you start deploying the same thing that's on production right now, there's no risk. You've eliminated that. The risk is the deployment, and that really wasn't the concern there. It was deploying lots of code where there might be bugs that you didn't properly test, or the users might break your thing or whatever. So start deploying. Make it a burdensome task. Fear and risk are the enemies of the continuous delivery right now. And if you don't address them, they're going to remain enemies for any sort of deployment, not just continuous deployment. So replace fear and risk with boredom and annoyance. I mean, you're all developers here. I mean, we probably have a bunch of shell guys here. How many things have you automated in your life? It feels good. Like you're dealing with something that's annoying as hell, and it's like, oh, now I just have to run a command. Moses said this right after, it was in a book. I couldn't find the exact quote, but you can probably look it up yourself. But it really allows you a lot more freedom, and it removes so much frustration in your life. And after a point, like when we start development, we start doing a lot of cool things, and then we get paid for it, and we start doing a lot of cool things that other people think are cool, and you stop doing a lot of cool things anymore. And you start losing the desire to get rid of all the cruft, because then it starts becoming part of your process. You get cruft after meetings, you get cruft before meetings, you get cruft dealing with other people, you get cruft in email, and then it just starts being part of your routine. So this is a change for you, and it's a change for process in the company, and it's encouraging people outside of technology to automate a lot of the things that they thought they had to do manually. So, because you're deploying every day, you automate your current flow. That way there's no hurdles in front of you. You don't have to worry about much of anything. All you're doing is getting it down to a button press or a shell script or something. Something where all you have to do is press enter and it's done. And at that point, to test to see whether or not you are legitimately, you have a legitimate pipeline, go to somebody who's not a developer. Go to customer support. Go to your CEO or something. I don't care. get them to deploy something. And this is the start of your pipeline. And there can't be logic in this script. What you're looking for is a series of automated tasks that lead to another, and once one fails, the entire process fails. You don't want to have branches because that gives you way too many points of failure. So traditional, continuous delivery is this three-step process where you complete something, magic happens, and then you go live. And your job is to figure out what that middle pipeline is. For a lot of people, it looks similar to this. You push or you get code to some central location, then you run unit tests, and by that I really mean fast tests that don't require your code to be built or talking to anything else. And then you build an artifact, and in this case, artifact means you build one immutable file. This can be an RPM, a war, a tarball, a Debian package, something that isn't like a directory full of random files. Because as soon as you start getting into that case, then it's easier to change a file here and there when you deploy it somewhere. You want to have one deployable artifact, and when you deploy that, it's pretty much done. Integration tests, and by that I mean tests that run more slowly and require your product to be built and probably talking to other systems. And then deploy. And deploy can be a wide variety of different things. I mean, you could use Chef. I mean, for all I care, you can SCP or rsync your code to a server. Like, it really doesn't need to be something that you worry too much about. There are many different ways to do it, and a lot of people get hung up on how that is actually done. As long as it's automated, it's cool. And each one of those steps has small pipelines of their own. And you have to figure out how to manage those, because that's where things start to break down and get very specific to your application. In a lot of JavaScript applications, if you're doing the pure JavaScript applications, you have something that might pre-process the code. You might have something that compiles the code, and this could be like a CoffeeScript or TypeScript, or even a require.js optimization. You could optimize all the files into one. You could cut out the dead code. Closure probably, and minify the code to make the payload a lot smaller. And Sass, I'm sure we all use Sass, less, stylus, something along those lines. So we have build processes in place already, and it's just time to formalize that. And now that you've done something locally and you can run a shell script, it's really important that you continually improve. You move forward and mature past this local process as quickly as possible, because if you stay there, then you're not going to move any further. You can use something like Jenkins. Jenkins is all I've really used because it's easy to get up. There's a lot of quirks to it, but it has a huge community, huge number of plugins. A lot of the plugins do need other plugins to work the way you might want, and the plugin interaction can get kind of flaky. This is a significant maintenance point. That you're going to have somebody who becomes basically your domain expert in Jenkins. Jenkins has easy Git integration. I'm a big Git guy, but you can use pretty much whatever you want in there. And includes parameterized branches, so that if you want to potentially deploy a feature that is on a branch, you could set that up in Jenkins. It has an at-a-glance overview, and that's something you should aim to get to, is having all of the state of everything easily visualized and up on LCDs in your wall. Like, to be in a company, you should, in order to not understand the current state of everything, you should open up the door, put your head down, close your eyes, fumble your way to your desk, and then sit down and start doing your work without ever looking up. Because if you have bare wall space, you're missing out on providing data to people in your company. And LCDs don't cost much. You can get LCDs anywhere. Buy a Raspberry Pi for 35 bucks. Get Jenkins up there. There's a Stoplight, I believe it's called, which is a quick 10-foot display for the status of a bunch of jobs in Jenkins. It's a great way to get an overview of what's running, what's failed, what's golden. And that's something that you can have in your engineering room, but it's really beneficial if you have it in some sort of corporate room, because that just provides visibility into what's going on, and you're less likely to let a red job sit. And you've got configurable pipelines, and in this case with Jenkins, all it basically means is setting up an origin job that will then trigger other jobs or have other jobs triggered from it. And it has good visualization plugins, so you can actually see things go through the process, and this is a great thing to get up on the wall. But you've got the yellow, not up here, you got yellow jobs that indicate something is currently working, then it goes green or red, and either fails and nothing else happens, or it continues down and you're in production. So if you're actually here, if you got Jenkins up, if you have your local local deploy script that actually works, you get that running up in a job, all you have to do is tie that into your version control system, and you're continuously deploying. It really wasn't that hard, was it? I mean, when it comes down to it, it's a lot of stuff that you already have to do, and you just wire it all up in things that you weren't using before. So one of the things that is important to deal with is how to actually get something from one place to another, and how to version those things so that you can roll back if you need to. And that's where bundling your artifact is important, and that's why you don't want to deal with a massive directory of files, because at some point managing those as versions is a pain in the ass. So you bundle what doesn't change, and then you move that artifact from step to step, so you don't rebuild something for a different environment, because that there's a lot of things that can go wrong in that process. So once you've built one thing and you start running tests on it, you need to move that one thing over and over. And in a somewhat traditional setup, these are environments, so this isn't the CI process or CD process, these are just different environments. That line would be the part of the CD process that actually gets the artifact built. And so after dev, you've kicked off the process and it's starting going, you have an artifact, it moves to CI. And the CI environment is, it's a classic thing to have, so that you have your CI and your CI process can have something it can rely on in order to run tests, it can do whatever. Ideally, people aren't touching that much, that's just mostly an automated environment. So tests will run there, they get the green light, that artifact moves over to staging. And staging is that process, that environment that is most similar to production. You might have it, you might not have it, you might have stage be part of your production environment, maybe isolated off to a subset of users or internal to the company. But it's the idea that that same artifact is what's being moved around. You're not rebuilding everything over again. Like if you're using Grunt or anything like that, it's not like you're running Grunt again on CI stage in production. You run it you run it once on CI, and then you move that artifact all around. So how is continuous delivery different for JavaScript applications? It is much, much easier in a lot of places. All you're dealing with static files, but then you're kind of shit out of luck because you're only dealing with static files. And that becomes kind of a pain in the ass, because you're delivering those, and once they're gone out of your hands to the world, you don't really have much leeway as to what they do anymore. You can do a lot of stuff in JavaScript, but then of course you don't want to have all those different environment settings in your deployed JavaScript, because that's not where they're supposed to be. So first you need to formalize what JavaScript development workflows actually are in your company. Are you minifying your JavaScript? The answer is yes. Then you already have the start of a build pipeline using RJS. People familiar with Require.js? It's a pretty popular module loader, but it comes with RJS, which is the Require.js optimizer, which bundles all those modules into one or multiple files. It does a lot of stuff for you. It copies everything over into what could be seen as a distributable, I'm not talking today, sorry, environment, minifies your CSS, can uglify your JavaScript, but as soon as you want to do something that's outside of the realm of that RJS optimizer, then you have to start dealing with it yourself, because it's not a tool that should be doing everything. Use Sass or CoffeeScript, Less or Stylus or TypeScript or whatever else, then you already have a pretty serious developer workflow. You got something where the question earlier, how easy could somebody get into your project? Are you going to have to document? It's like, well, you first have to watch the Sass over here, and then you have to start up CoffeeScript to watch your CoffeeScript. You have to make sure that you're loading the right directory in order to be serving the appropriate source. Those are things that need to be automated so that you don't have them in a document. And in that case, you need a task manager. Are we mostly familiar with Grunt? Okay, cool. So, well, Grunt is a task runner and task composer. For anyone who isn't familiar with Grunt, you can define your own tasks in pure JavaScript. There's no real magic going on. And you can use loads of community tasks, and you can define task chains that are composed of your task, community tasks, and even other task chains. And they all execute in order, and if one fails, then the whole build fails, which sounds familiar. And these are just some of the tasks. The Grunt contrib team maintains like about 40 or 50 tasks which are officially supported, so any changes with Grunt are very quickly adopted by all the Grunt contrib tasks. So for a lot of things that are very important, which a lot of task delegation to JavaScript libraries like uglify.js into whatever, those are taken care of, but also common commands like copy, concatenation, things like that, those are updated relatively quickly. But there's a ridiculous number of other tasks. So Grunt has its place all throughout your build system, but where you're really going to benefit in this talk anyway is dealing with your developer and build workflow. But you could automate your pushing with Grunt. You could automate your versioning with Grunt. You can do easily unit tests, build artifact integration, and you could even deploy. But I haven't done that. I'm not sure it's really necessary. So the task chains that I generally set up by default are here. As a test task chain, which is that's not a task in itself. That's a chain of things that do testy type work. A build task chain, which does all the stuff necessary to get it visualized in dev and potentially in a dist build. Artifact, which in most of my cases is just compressed, because at the end of the day, all I really want is a tarball. But that could be RPM, could be something along those lines that builds up your artifact. And then dev is a task chain that test builds and watches, and dist build is test build and artifact. Real life task chains get much more complex, but this is a pretty decent way to start, and it gets you set up for a pretty solid start to not even necessarily continuous deployment, but also just deploying JavaScript libraries to GitHub or something like that. Your dist build could just be minifying the code, and that's your artifact. You have one minified library. So this is not, this Grunt, the rest of the talk on Grunt is not going to be strictly for continuous deployment. It's for general decent practices by my standards, how to deal with Grunt in this way. So there's a lot of testing opportunity. I'm not going to go too deep into it, because I think there have been a couple talks on PhantomJS and testing so far. There's Grunt contrib Jasmine, contrib QUnit, and there's Mocha and Karma, which aren't contrib, but still very well supported. They're all awesome, and you also may get even some benefit by moving to that. So even if you do have tests in another way, it might be beneficial for you to still move there, so you get the headless testing. And also, at least Jasmine, I'm not sure about the other ones, but you can get code coverage statistics and reports, and also JUnit XML. So if you are using something like Jenkins, you can get a quick overview of what passed and what failed relatively easily. And also, I'm the maintainer of Jasmine, and it's the Grunt contrib Jasmine, not Jasmine library. I built it specifically so that you don't have to deal with the HTML spec runner. So people who have dealt with Jasmine at one point and got frustrated actually like adding source files or spec files to the HTML runner. This was the reason I built that in the first place, was to completely bypass that part of running Jasmine. So you can still run tests in the browser and not deal with the spec runner cruft. There's also templates for it, so if you're using require.js or if you're using, I think there's like Steel or something like that, there are templates that make the process of testing those things easier, so you don't have to deal with your own HTML setup. One of the biggest issues with continuous deployment or any sort of thing dealing with HTML is that you have no leeway whatsoever when it comes to HTML. What you're basically set up with is one static file that directly links to other assets on your environment. So you're basically, you need to either replicate your entire environment across all environments, so you have all the directories set up the same, or alias the same, or whatever else on dev and production, or you need to maintain two separate sets of index HTMLs, whatever else. Or you could set up a server to dynamically serve up pages depending on the environment. But if you're dealing with a strict JavaScript application, that's really entirely unnecessary. And if you're deploying to something like, let's say, Firefox OS even, or Chrome Web Apps, that's not an option. So one of the things that we built at One Health when I worked there was the Preprocess module and Grunt Preprocess, which is the task that delegates to Preprocess, but allows you to have intuitive variables inside HTML, so that once processed, they will just be purely injected. It makes it easy for things like dynamically loading the configuration, so that you can load it depending on the environment. And these are all environment variables, so you can set these up on the shell right before you run Grunt, and that makes it easier to incorporate with other developer tools. other continuous delivery tools. You can also change things. These are just some examples. CDN URL. So if you have something on local, which is just a local directory somewhere else, then you have a legitimate CDN on S3 or something like that. You can substitute it that way. You can have conditional comments, and if you look at the top one, the script tag is not commented out, so that will run even if the file is not preprocessed. And the second one, which is I guess a negative conditional comment, you could call it, is commented out, so that won't be executed on without being preprocessed. If we do preprocess it with an environment set to dist, then you get the second one, not the first one. If you did happen to preprocess it with an environment set to dev, then you'll get the top one and the bottom one, but that's not necessary in this situation. There are other preprocess directives, if in def, if def, which just tests for the definedness of a variable. It's a common thing to do when dealing with anything delegated to a shell command from the shell is just to initialize a variable with whatever value, and then if it's defined, do something. If it's not defined, do another. You can include files, so you can extract a bit of that HTML somewhere else and then preprocess it so that it gets bundled in together, and that's a good way for inlining a lot of code that you don't want to have to maintain in an HTML file. You can exclude, which are just blocks that upon preprocess will just get excluded automatically. It's a good way, like if you want to have a dev banner at the top or a certain environment banner, so you're always reminded you're in that environment, then as soon as you get preprocessed, it removes that and can go on into production. And echo variable is just to get variables into the HTML. And once we started doing that, we realized it was probably useful to also have the environment set up in Grunt. So we could have more elaborate environment configurations that will also cascade to other tasks and also shell commands that Grunt spawns off. So if you start dealing with a lot of past configuration and you start maybe bloating the Grunt configuration, it might be easier to have those either in the Grunt env configuration or in a separate .env.json or .env file, which you might have used for Heroku or things like that. And it allows you to bootstrap your entire build process a little bit more intuitively. So in these situations, using those two tasks to specify, I'm not sure how familiar everyone is with Grunt, but to specify subtasks of a task, use the colon blah. And in this case, you just have env dev build, and then the second one, if you needed to use preprocess, you env dis build preprocess. If you want to use variables, then you would of course have to preprocess the dev file. So there's an initiative right now to have a Grunt files GitHub organization where a lot of people will hopefully contribute their example Grunt files so that people who are looking for different ways of developing applications can get examples from people who have done this before. There's one of the examples that I put up recently. It's a Browserify Grunt file configuration. So it allows you to set up a quick Browserify application using Sass and whatever else, and sets up the task chains in the way that I personally recommend for continuous delivery or just the full delivery process. And it shows you examples of how you can actually flesh out some of those default tasks. So a test you can just have JSint node unit run. For people who aren't familiar with Browserify, it allows you to write front-end code in Node.js style, so that you can test it pretty easily with the same things that you would test an NPM module with. Build, in this case, we Sass, Montage, and Browserify. Sass is obvious. Montage is a Grunt task that automates the generation of sprite sheets. So you can have a directory sucked in, it'll create a sprite sheet and also the CSS style that you can associate with the file names as classes. So it's a great way to get a bunch of image optimization there. Artifact in my case is almost always compress. And the dev task chain, which a lot of people may have conflicting ideas about what you should be actually building before you see anything. There's some people that don't think you should have a build process at all. I am on the other side of the fence where you should start with a build process. It gives you a lot more flexibility in what you can use. If you're looking to get something in the browser and you want to have modules, you want to have a CSS preprocessor. If you were looking to not have a build process at all, you're pretty much just allowed to use require.js unless, maybe Stylus, I'm not sure if they do it. But if you want to use Sass, then you have a build process. And Sass is pretty popular and common, so if you have part of a build process, just formalize the whole thing. Get everything organized into one flow so that you don't have to worry about different commands. And in this case, sets up the mdev. In this particular example, it's not actually used, it's just put there as an example. Clean dist, so that when you start and when you initiate that developer workflow, it automatically wipes away the previous distribution, so that there's no confusion as to what the current state of dist is. And you test, build, and watch. And dist build, set up the environment for build, test, build, copy everything to a distribution directory, you uglify the necessary files, and you preprocess the whatever HTML is appropriate, and you artifact it. And that generates a tarball in the root of the directory of the entire dist directory, so that you can just untar it anywhere, and bam, you've got your application. So, whew, I should have been drinking this whole time. Continuous delivery is not a quick change. We already went over why traditional delivery exists, how hard of a process it may be to move, and it is going to require you to buy in, and it's going to require you to not let up. Once you get a week away from your last deployment that was a pain in the ass, the pain of it starts dissipating, and you don't really remember what a burden it was. So it makes it easy to reduce the importance of continuous delivery, and then you start deploying every day, and come like the 4th or 5th day, it's like, oh, I'll do it tomorrow. And then the next week, you just don't do it at all. And it's very, very easy to get into that, but then you get to the next deployment, and you might have your deploy script, and you're starting over, but you're not quite all the way there. There's a lot of benefit to continuous delivery. It changes the entire company's workflow, and it encourages people to start thinking about features and user stories, whatever else, in smaller granularity, so that you can start getting things out sooner to your customers and start getting more feedback more quickly. So it's going to be probably up to you to start this process, but once you start getting other people to buy in, it gets easier. Don't think of this as just a technical process. You're not just delivering code. You're not the only one who's going to be continuously delivering. It's the entire company that needs to be bought into this. So it's going to be some work for you to start doing it, but it's worth it. Once you get there, you'll notice a drastic change in how comfortable you feel delivering the features that you're delivering. So there's tons of resources for Grunt. Gruntjs.com has a ton of documentation. There is an initiative right now from a few of the core Grunt guys to provide better documentation and examples and screencasts and blog posts, whatever, to get people up and running with Grunt, because it does have kind of an annoying learning curve. Once you get past the annoying part, then it just becomes core to what you're doing in JavaScript. There's the Grunt Files GitHub organization, which has a few up there right now, but also anyone's recommended to touch it. And that's all I got. Again, my name is Jarrod Overson. You can find me just by Googling JS Overson, apparently. It's not JS for JavaScript, it's Jarrod Seth, some guy in 2004 had joverson@gmail.com, and ever since then I've been JS Overson. The bottom two, GitHub and Twitter, you can inverse the domains and the names and get me. That's me. You can poke me whenever you want, you can do whatever you want. I love to chat about this stuff a little bit to excess. I'm kind of a huge JavaScript nerd, so if at any point in time you see me wandering in the streets, just buy me a beer and I'll wax nerdy about Node and Grunt or whatever else. Cool. So questions up here. Feel free to bolt, just exit the room, get people up more if they want to talk about Grunt, continuous delivery, whatever else. We can have a nice fun chat. So there was a question over there. Feel free to come up to the microphone so I can hear you.
So how does QA fit into this?
Personally, if you want to go there, I've worked to great effect having QA pull from my local Git repository. So not pushing to origin for anything. So at any time I make a commit, QA can push, test the current status of everything, and that way they are literally testing exactly as you're working. You don't have to wait for massive pushes to origin once you have a comfortable number of features in there. As soon as you make a commit, QA can push your current set of commits, reset to your remote, and they can start QAing. So I recommend very, very heavy integration between development and QA, but also to have QA be writing more serious tests that are against the entire application, so for integration tests or whatever. But for the small testing that would be normally around a certain feature, to be heavily integrated to the development process.
Cool. Do you deploy directly from your master branch, or do you have a branch just for deployment?
Master. Yeah. You can do it from master and have something else development or features, whatever, and it's up to you. I like the idea of master being as close as possible to whatever was in production.
Do you have multiple branches, one for development and one for production?
No. No, you can. It depends on your flow, and it really comes down to what you feel most comfortable doing. What I generally have been more comfortable doing is having feature branches when necessary, but again, if QA is pulling from you, then you don't necessarily need to ever get them to origin. But if you do need to collaborate with other developers, whatever else, then push them to origin, and then once they are merged into master, then merge them and delete them.
Can you talk a little bit about what happens in the event that, let's say you deploy something and it breaks, the site? One big generator of fear is that, we're not going to figure out how to revert back to the older version. So what systems do you have in place to quickly sort of roll back?
That's where having the version artifacts helps a lot, because all you're doing is, if you're using a tarball, all you're doing is untarring the last version there. And you can do that in Jenkins, though I would recommend having some sort of artifact server and then a deployment process that deals with the artifact server so that you can set up which version is actually going to be deployed. But you could have your deployment happen from the last successful production build of Jenkins, so that all you would do is promote the last artifact up to the last successful production, and Jenkins, whatever you're deploying from can pull from there. So if you have those artifacts as opposed to just giant directories or even throwing them away, all you're doing is you have a series of last successful production releases. So in that case, so when you have a problem, you can just deploy the last one. But also, ideally, since you're developing very, very small bits of code, when you do have a problem, all you do is fix it and then roll out something new. So there's the mantra, always roll forward, which encourages that aspect, so that you don't really have rollbacks anymore. You just fix your problem and then move forward. So you don't really have worries about massive failures because you're not deploying that amount of code.
And those artifacts are gigantic tarballs of the entire,
Yeah, well, whatever you feel is appropriate to deploy. If it's like if it's a static website, it'd be like your htdocs directory or something like that, whatever would be seen. If it's a Java application, maybe it's your war or something like that. But yeah, they can be big, but it also encourages you to remove some of that stuff. So if you are bundling a lot of images or anything like that, it would encourage you to pull that off to a CDN, so that what you're actually deploying is just what's actually changing.
Gotcha. Thanks.
Cool.
So you mentioned that you're using the same artifacts on your staging, continuous integration, and production environments. In case the front end and the back end are independent, completely independent, how do you test your front end if the back end has to be different for each of these environments?
Well, that's a different talk. Then it requires a pipeline that incorporates releases to both. So each one of those steps of the pipeline would then be deploying to both, and then you would have some sort of process that's kicked off when both of them are successful. So this is mostly for JavaScript applications where you wouldn't actually be dealing with a server. So the flow would definitely change, and you'd have to account for that. But also, if you're deploying everything from master as quickly as possible, then unless you're having sweeping changes to both, where it has schema changes to one or API changes, and you need to have those on both sides, then you should just be able to roll with what's continuously rolling out. So you roll out with whatever is most backwards compatible at the time. So let's say you're deploying an API with the front end changes. If you have other clients accessing the API, then you have to be somewhat backwards compatible. In that case, you just roll out the API, REST API, SOAP API, whatever you're doing with, and then it doesn't matter. Then you just roll out the front end whenever you feel like rolling out the front end.
So we have a slightly different sort of release pattern. Let's say we ship probably once every 6 months. So I wanted to get your thoughts on how some of this would be applicable to our release patterns and so on.
Well, what are you releasing?
It's enterprise software, so it's not.
So then don't have to necessarily continuously deploy to your end user at all times.
Yes.
But you can continuously deploy to what would be a finished product at all times. So if you're delivering something every 6 months, presumably you have some sort of state before that where like people test it or whatever.
Right.
You continuously deploy in that, and if it's getting it out to users, then you continuously send that out to test users or whatever along those lines. So you don't necessarily always need to be releasing directly to production, and that's something like that stage environment. There could be a business gate there where continuous deployment for all intents and purposes can just always be deploying to staging. And that way, for developer and QA, it's done because all it's doing is waiting for a button press to be pressed by somebody else. So it's flexible to whatever is appropriate for your needs.
Thank you.
How do you feel about code coverage and continuous deployment?
I think it's great. I think there should be, that would extend the talk a bit, but for all sorts of metrics and stuff like that, those should be incorporated into the failure process. So if you add code and your code coverage goes down, that fails the build. And if you have complexity metrics and your complexity goes up, that fails the build. If you have the logins per day or whatever, and you deploy something and your logins go down, that automatically rolls back everything, and that fails the process. But yeah.
Do you recommend any packages?
For code coverage?
Yeah.
There's a custom template for the Grunt contrib Jasmine that uses Istanbul, and that if you're using Grunt contrib Jasmine, all you need to do is just switch the template you're using, and you got code coverage.
Thanks.
Mine's pretty specific, but I just started using Grunt contrib Jasmine like last week, and
please submit PRs.
It seems to be conflicting with required.js, and I was just wondering where I could find a good example of how you're doing it with required.js to get it right.
I initially created a template specifically for required.js. Are you using that one?
Yeah.
Okay. There is an example of, I think it's in my GitHub repository, Grunt contrib Jasmine required.js example, maybe? I don't know, something along those lines.
There's an example there?
Yeah, and it definitely requires you to structure your required.js code in a certain way, and no matter how you test required.js, you're going to have to do it in a specific way. So that's why it's beneficial to see how other people are doing it with that template, and what the best practices are for people who've had a lot of familiarity with that. Right now, I think, I just transferred that template over to CloudChen, which is another developer, because he's taken a much more direct role in managing that. So it'll be under his repository, but you can still install it the same way.
Okay, cool. And one other thing, you have a server kind of in your default required.js template where you want it to run. So on your development servers, do you just keep that port open as well? So like we have security groups, we run all of our development servers in the cloud basically. We only have certain ports open. Do you just leave those ports open so you can run those testing servers?
If it was on a separate server, then it might be better for you to make a template that is more appropriate for how you would plan on testing, and you can use that template as an example, just not have it not have Grunt spawn a server, because that was specifically done for local testing. So you would spawn up a server and then it would run that and then would kill the server.
Okay.
But if you're developing on an environment that can already serve your files, then it might be more appropriate for you to set it up so that you don't have to worry about any different configuration.
Okay, that was my thinking. All right, thanks for the talk.
Thanks for coming.
Hi. Great talk. I've been participant in a number of organizations that do not use continuous deployment, that have independently come up with the do not deploy on a weekend or near a weekend rule. Does continuous deployment, in a continuous deployment environment, what happens during the weekends?
Whatever you want. I mean, if you have developers actively working on weekends, then I would leave it to the discretion of the people who are working on weekends. But if at any point there could be a problem somewhere and you would have to bother somebody, then just be nice.
Okay, thank you very much.
Good. Hey.
One question regarding serious changes like model changes, schema changes, Are there things that you would like to have people watching, these critical deployments, these huge scripts transferring data, and it's not rollbackable all the time, so how do you handle that?
It would be custom to your situation. In your experience, would that normally be involving downtime of your application or anything like that?
Usually not, if it works correctly.
Yeah,
if it all goes well.
In that case, you could have the deployment process deploy to other servers, make sure that everything's okay, keep the other servers up. If it is okay, then just kill the other ones and have your deployment process go to those new servers. I mean, that's more, I guess, forgiving in a cloud type environment.
I guess the problem is the data. The code, yeah, you can always put it, but if you're touching your production data, especially if it's big data that you cannot easily recover and return from backup or something like that, then I think this is the main thing. Code is simple, data is difficult.
Yeah, in that case then, try to only do changes that don't require massive migrations or alters or anything like that. And when you do need those, then that's going to be a serious deployment. And you're going to have to organize that process. That's not something you want to optimize for in a situation like this, because ideally those aren't happening very often. So there's no simple solution for that. You would do it the way you do it now.
Basically turn off the Jenkins and do it manually. Thanks.
All good? Cool. Thank you very much.